Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. Enjoy! First thing we need to do is work out the area of the wall. And so to do that, we're just going to multiply the 44 by the 40. So 44 times 40 is 1,760. And next thing we notice is that each tin covers 10 meters squared. So it actually means we can work out the fact that there are 1,760 meters squared in total for our wall. And if each tin covers 10 meters squared, then we will need 176 tins. That's the amount of tins we need. And each tin costs £5.70, so it'd be 176 times the 5.7, or £5.70, or you could do it as 570 pence and convert it at the end. And that gives us a price of 1,003.2. And so as money, that would be £1,003.20. The median is the middle number when the numbers are in order. Now it's quite difficult to do with a table, so we used a formula, and that formula is to find the position of the median. We do how many numbers there are, which I'll call n, we add 1 to it, and then we divide that by 2. And that shows us where the median is. It doesn't tell us what the median is, it shows us where it is. Now, we need to figure out where these numbers are in this list. So the first number is a 2, and there is one of those. The next number is a 3, and there's 3 of those. So 1, 2, 3. The next number is a 4, and there's 4 of those. So 1, 2, 3, 4. The next numbers are 5, and there's 8 of those. So 1, 2, 3, 4, 5, 6, 7, 8. And the next numbers are 6, and there's 13 of those. Now I'm not going to do all of them, okay, because we're not going to be working out the median by writing out all the numbers, but I do want to show you where these numbers are coming from. So what we do is we do a running total. So I'm going to do a running total. The running total is just adding up the frequencies as we go. So the first one is just 1. Then we're going to add the 3 in the next row, so that's 4. Add the 4 in the next row, 8. Add the 8 in the next row, 16. Add the 13 in the next row, and that would be 29. Now, we use the running total because the running total shows us where the last number is in that group. Okay? So this shows us that the first number is the last number that is a 2, which is true, we can see it here. This 4 shows us that the fourth number is the last number that's a 3, so let's check that. 1, 2, 3, 4, it works. This 8 shows us the 8th number is the last number that's a 4, let's check that. So 4, 5, 6, 7, 8. This 16 shows us the 16th number is the last number that's a 5. So 9, 10, 11, 12, 13, 14, 15, 16. And this 29 here shows us that the 29th number is just the last number, but it's the last number that's the 6th. Okay, so let's work out how many numbers there are. And we do that by adding up the frequency. So we're just going to add up all of the frequency together, and we find out that there's 29 numbers altogether. So 1 plus 3 plus 4 plus 8 plus 13. So using our formula, which is 29 plus 1 divided by 2. 29 plus 1 is 30, divided by 2 is 15. So we're looking for the 15th number. So looking down our running total list, well, the last number that's a 4 is the 8th number, so we haven't got to the 15th number yet. And the last number that's a 5 is the 16th number. So if the last number that's a 5 is the 16th number, then surely the 15th must also be a 5. And so our median is 5. All probabilities have to add up to 1. So what I'm going to do is I'm going to take away these probabilities away from 1. So we're going to do 1 take away 0.09 plus 0.13 plus 0.18. And so that's going to be 0.4. 1 take away 0.4 is 0.6. A side elevation is the view you'd get if you were standing at the side of a shape. So I'm standing here and it's the view I'll get. Well, it would be this trapezium here. And to know which side is the side and which one's the front, well, the front is always going to be labelled. They do normally label the sides as well for you. So we're going to draw this trapezium. So the top bit is 3, then it's 6, then it's 8. So I'm just going to start off with the bottom actually, that might be easier, and draw the 8 across. 1, 2, 3, 4, 5, 6, 7, 8. Then I'm going to do the 6 up. 1, 2, 3, 4, 5, 6. Looks like I left just enough room. Then I'm going to do the 3 across. 1, 2, 3. And then all I need to do is just join up the start and the finish to complete the trapezium. To answer this question, we basically need to find the lowest common multiple of the 10 minutes here and the 15 minutes here. So we're going to start off just by doing the 10 and 15 times table. So it'd be 10, 20, 30, and 15 times table with 15 and 30. So the lowest common multiple is 30. So after half an hour, these buses will sync up. They'll both leave at the same time. And all buses start service at 9 o'clock. So it will be half an hour after 9 o'clock, which will be 9:30. To answer this question, we're going to have to create a two-way table for all the information. So I'm just going to draw a quick table. So we've got maths, English, science, then a total column. And then across here we have male and female and a total column. Okay, so gonna fill in maths at the top, English, science, and then we have a total. And then we've got male, female, and then total at the bottom. So looking at the information we have, it says there are 43 students who are male. So altogether the total male is 43. 30 out of the 52 students who went to science were female. So we're just looking at science, and 30 were female, and it says there were 52 altogether. 37 students went to English, so total for English was 37. And then 17 females went to maths. So looking at maths and females, which would be there. So that's all the information we're given, apart from the 115 as well. There we go. So we start filling these in. So looking at these two, if there are 115 students altogether and 43 were male, that means 72 will be female. Looking along the bottom here, the total of English was 37, the total of science was 52, and the total altogether 115. And notice I'm not necessarily reading the question here, I'm just filling out the two-way table, but we'll read the question at this point. So it says work out the number of males who went to English. Males who went to English will be this box here, so this is our target. But you can't work that out directly, we've got to kind of go around and work out what we can. So the next thing we can do is work out this bit here. So the total females 72, the females who went to maths 17, females who went to science 30, so that leaves 25. And then you can see here we can work this out. So the total was 37 who went to English, 25 females, and so that means there will be 12 males. There's a formula we use for this, and it is percentage change is equal to the amount that's changed over the original amount, and all of that times 100%. So how much has changed here? Well, we need to do 10,488 take away 10,254. So that would be 234. Divide it by the original. So the original was 10,488 because it's decreased from that amount. And then times by 100%. And so that's going to be 2.23%. So to find the probability, we're going to do the successful outcomes divided by the total number of outcomes. So looking at this question, it says number of times it should land on a 1. So that would be 1 over the total amount, which is 11. So the chance of us getting a 1 is 1 over 11. To find the expected amount, we do the probability and we times it by the amount of trials. So it says it's spun 60 times, so we're going to times it by 60. And that will give us the answer of 5.454 blah blah blah. Now it can't have landed on a 1 5.4 times, so it's definitely, well, this probability, we always round down, so never ever round up, because it's 5 times and then a little bit extra, and so only when it gets to 6 can we say that it's 6 times. So the answer to this is just 5. In this question we've got euros and we've got pounds, and we're told that £1 is 2.23 euros. And we're trying to get to understand what 2,676 euros is in pounds, and we're going to do that by finding out what €1 is and then finding out how much 2,676 are. So to get from 2.23 to 1, we divide by 2.23, and we're going to do that on both sides. And when we do that, we get 0.448 blah blah blah. And then to get from 1 to 2,676, we go times by 2,676 on both sides. And when we do that, we get £1,200. So 2,676 euros is £1,200. The first piece of information I'm going to focus on is the fact Denver gets 8/19. Denver gets 8/19. That means that Engel and Fido together must get 11/19 because they have to add up to 1. So we're only looking at 11/19. I'm going to focus on the ratio next of Engel to Fido. So it's 9/5. And let's have a look and see, well, first of all, how many parts there are all together. So 9 plus 5, which is 14 parts. So there are 14 parts in total, and the share that they get is 11/19. So what I'm going to do is to find out what fraction one of those parts is worth by dividing 11/19 by 14. So each part is worth, and I'm just going to keep this into my calculator, 0.041 blah blah blah. And we're asked to find Fido's share. Well, Fido has 5 parts. So Fido has 5 parts, each of them worth 0.041 blah blah blah. I've kept it in my calculator to keep the accuracy. And when I do that, I get 0.206 blah blah blah. Now we're asked to work it out as a percent, so I'm just going to times that by 100. So we have 20.676 blah 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 percent, and it wants it rounded to nearest percent, so that would be 20%. Or actually, it would be 21% because this would round it up. So 21%. Any number to the power of 0 is equal to 1. So it doesn't matter if it's a number or a letter, it's always going to equal to 1. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got two sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason. So corresponding angles. And corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We'll go first of all add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. So the first thing we need to do is work out the mean for the data in the table. So to start off doing that, we're going to work out the midpoint of each group. So we've got 80 to 85, and to find the midpoint, you add the 80 and the 85 together, then you divide by 2. So this will be 82.5, then 87.5, then 92.5, then 97.5, and then finally 100 plus 105 divided by 2 is 102.5. Next we need to find the FT, which is just the frequency times the duration of calls. Now, in this first group, we're not timesing it by 80 to 85 or anything like that. We're timesing it by the midpoint. So our midpoint effectively becomes the t. So we're going to do 15 times that, which will be 1237.5. And we're just going to keep going and multiplying each of these together. And then finally 2050. Right, next we need to add up the frequencies and add up the FTs. So we're going to have the sum of the frequencies. So I'm just adding all this column up, and that will be 80. And we have sum of the FT. And so we're going to just add this column up here. And so that would be 7,450. So what this column represents is all the numbers added up together. This column represents how many numbers we have. So to find the mean, it's all of the numbers added together, which will be 7,450, over the amount of numbers we have, which is 80. So when you do that, we get 93.125. Now this question is about the improvement that we've made, or that the manager has made, the call centre's made. So we're looking at subtracting the 93.125 away from the last week, which was 105. So we're looking for improvement. And we're going to do 105, take away the 93.125. And that's going to be 11.875. Now it does ask for 2 decimal places, so that will be 11.88. The first thing to notice is that the tree must be closer to CD than AB. So if we draw a line across the middle, it can't be in the top bit because that would be closer to line AB. The second piece of information that is given to us is it must be at least 11 meters away from point C. So we get our compass out and measure 11 centimeters, or whatever the scale we're using in this diagram is, and we draw a quarter circle from C. And it says shade the region that it can be planted. So this is the region that represents closer to line CD than AB, but also not within 11 meters of point C. So factorise means to put it into a bracket, and it looks like it's a quadratic here, but it's actually just a linear factorising. Because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10. And that will leave 2 and 3. So that's the numbers done. Next I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally I'm going to look at the u, and there's just a u on both of them I can factorise out, and actually that just leaves nothing on the inside of the bracket. Now always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30 times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. To answer this question, we need to know what an equation, expression, formula and identity is. So the formula is basically an equation but for real world things. So area equals pi r squared. It's where the letters actually mean something. Expression is just algebra without the equal sign. So 5x plus 3 would be an expression. An equation has an equals and it can be solved. So you can find out what x is or find out what a is. And an identity is true for all values of that letter. So an example would be x times x equals x squared. That's an identity because that's true for all values of x. So looking here on the right hand side, we've got 3x plus 2x. But if we imagine x is 10, so 3x would be 30 plus 2x would be 20, 30 plus 20, well that will equal 5x, 5 times 10. And actually this is true for all values of x. And the reason it's true for all values of x is we know that 3x plus 2x, this right hand side here, equals 5x. They're the same thing. Now normally with an identity, it's shown with 3 lines. Now in the exam, this type of question, it won't be shown with 3 lines because that kind of gives it away that it's an identity. But this question is definitely an identity. And you can't solve it because it's true for all values of x. So yes, x could be 10, x could be 1,000,000, x could be 1/3, x could be anything. The first thing that we can actually work out for this Venn diagram is this part here. So it says 12 had a cat but not a dog. So the cat but not a dog is showed with this A here. So if 12 had a cat but not a dog, and in total 22 had a cat, we're going to do 22 take away 12, which is 10. So 10 had a cat and a dog. If 16 had a dog, and 10 also had a cat, that means that 6 had a dog. Let's make sure we fill these in. And if overall there were 31 people, and there were 12 who just had a cat, 10 who had a cat and a dog, and 6 who had a dog, that leaves 3 left over. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line, and we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11,010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10, 990. Now when we're looking at limits, with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,005, and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that V can be anything above the 10,995 and including that, and it can be anything below 11,005, but it can't include that, because if it did, if it was 11,005, it would have rounded up to 11,010. So we're asked to find the bearing of Freetown from Gamley, so that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got 90 degrees here, we've got hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, so we can cross that out, and we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA. And so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in. And we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah, blah, blah. Okay, so we know that the whole of the way around up until this point is 270, because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270 take away the 26.565, blah, blah, blah. And that gives us 243.434, blah, blah, blah. It says it wants it to the nearest whole number, so that's going to be 243. Whenever we draw a curve, which here we have a reciprocal here, we need to draw lots and lots of coordinates, and then we join them up with a nice smooth curved line. So we're going to do, basically we're going to go up in halves. and 3. Right. So we're going to start with -2, and we're going to type that into the calculator using this formula here. So we've got 1 divided by brackets -2 plus 8. When you type that in, you get 7.5. Could do the same thing with -1.5, and you get the answer of 7.3 recurring. Same thing with -1, you get 7, and -0.5, you get 6. Now, when you put 0 in, whenever you have 0 at the bottom of a fraction, you'll just get a maths error. It's basically you can't divide by 0. So that does not exist. That's a positive infinity, negative infinity, or undefined, as mathematicians will call it. It's not technically infinity, it's a long story, but it just can't exist. So let's keep going. So we've got 10 for that, then 1 is 9, then 8.6 recurring, then 2 is 8.5, then 8.4, and then this would be 8.3 recurring, blah, blah, blah. Okay, now we start plotting this, and this is not going to be easy because the scale is going up in 2s. So 7.5 would be about 3/4 of the way up here. Then we've got 7.3, which would be slightly lower. Then we've got 7, which will be slightly lower. Then we've got 6, which would be a lot lower. Okay, then we've got at 0.5, we've got 10, then 9, should be, yeah, be about there, then 8.6, 8.5, 8.4, it's very difficult to do it from these ones, 8.3, okay. Now, this 0 here, it kind of tends towards infinity, both positive and negative. On one side it goes towards the positive infinity, on the other side it goes towards the negative infinity. So what is helpful to do when you're drawing this line is to turn your page sideways. And I'm going to try my best here. I can't actually turn this sideways, so we're going to try our best to connect these up. And I've got kind of a weird hand angle going on. So this is going to go towards negative infinity. This side, you can see it's going down there. And you can see this side here, on the right hand side, is going towards positive infinity. So, like that. Now there's no, there's a lot of leniency. You can see that I've probably gone too far to the left there. And so really what it should be is a little bit less dramatic, maybe, more dramatic, I don't know. So I think I've done exactly the same thing. But all of what I've drawn will give you the marks. They are very, very lenient when it comes to this. The big things with this is that this line here can't go to the left of the y-axis for this question, and this line here can't go to the right of the y-axis. Essentially, the y-axis, where x is 0, this line here, the left-hand line will never cross the line, and the right-hand line will never cross that line. That's where it flips between being negative infinity to positive infinity. Kind of, it's a way of visualizing it. And you can see here, the more points you've got, the better. And with reciprocals, really what we want is the points to be between 0.5 and negative 0.5 for this question. So we could do probably another coordinate at a quarter and minus a quarter would help us. And yeah, that's how you plot a reciprocal. So what's happened here is that the company's increased the amount of sweets by 15%. So we're just going to focus on that and work out what the multiplier would be first. So they started off with 100% and they added 15%, and then therefore they ended up with 115%. And to find that as a multiplier, we get the 115 and divide it by 100, and that gives us 1.15. So that is the multiplier they used. Now, they used that multiplier on the original amount, and they times it by 1.15, and they got the answer of 69. But if we're working the other way to find out what they times by 1.15, we get that 69 and we divide it by the multiplier. So if we want to work out what the original number was, we divide it by the multiplier, and that gives us 60. So the answer will be 60. It's sometimes easier in these questions to view these triangles as two separate triangles rather than one triangle. So we're kind of just going to split this triangle off and just move it to the side so we can see what's going on. I'm going to do the same with the smaller triangle and kind of move that to the side. So we can see we've got two triangles here. We've got a big triangle and a small triangle. And we can label the sides of them as 18. Now this long length would be 20 plus x, 20 centimeters plus x. Then we've got 6 here and we've got x here. Now the two triangles are similar because the sides here we assume are, we know they are parallel because they are right angles. And they share an angle here, which we can just label as A, and so they are definitely similar, which means that one is an enlargement of the other. So we need the scale factor first. Now if you look at the 6 and the 18, they are what we call corresponding sides. So we need to work out the scale factor by finding out what I multiply the 6 by to get to the 18. Well, that's obviously going to be 3. So we now know that we can times the x by 3 to get to the 20 plus x. So we can write that down. 3x, I'm timesing the x by 3, and that will give me 20 plus x. And so I can solve this now. Subtract x both sides. Always subtract the smaller amount, so 2x equals 20. And then divide both sides by 2. And so we've got x equals 10. So we know that x equals 10, it says find the length x, and so that will be 10. So we're asked to find 3a minus 2b. So let's work out 3a first. 3a is going to be the top times 3 and the bottom times 3. So the top times 3 is 9, bottom times 3 is 6. Then we're going to work out what 2b is. Again, times the top by 2, times the bottom by 2. And so 3a take away 2b is going to be 3a, which is 9 at the top, take away, and then the 2b, which is minus 2. And then the bottom will be 6, take away, minus 4. And so that's going to be 9 plus 2, which is 11. 6 plus 4, which is 10. So the vector is going to be 11 at the top, 10 at the bottom. A box plot starts with the lowest value. Then it goes to the lower quartile. So we have the lowest value, then the lower quartile, and then we have the medium, then the upper quartile, and then the highest value. So lowest value is at 1 on this one, and normally we just put a little kind of line at the end here. So we're going to put a line at 1, and I'm just going to put that line there. Ooh, a little bit further to the right. There we go. And our lower quartile is 9, which is kind of where the box starts. So we're just going to start a box there. We're just going to connect these up. There we go. And our median is 11, so we're just going to show that. Quite a thin box plot so far. Now it says the interquartile range is 5. Now the interquartile range is the distance here, so that's 5. So it's going to be 5 more than the lower quartile. If the lower quartile is at 9, it would be 9 plus 5, which will be 14. So if we get our line at 14, and then complete our box plot. Here we go. Now the range is the total distance of, or the total width of our box plot. So that's 17. So that's going to be 17 higher than the lowest value. Now the lowest value is 1, so 1 plus 17 is going to be 18. So I'm just going to, there we are, and we're going to have that at 18. And again, I'm just going to put a line there. So the first thing we're going to do is just write out the sequence. So 25, 40, 65, 100, 145. And we're going to just find the differences. So this is going up by 15. And then this is going up by 25. So they're not the same. This is now going up by 35. And then this by 45. So the differences aren't the same, but the difference of the differences is the same. And when you've got a difference of differences being the same, we've got a quadratic sequence. So the first thing you do with a quadratic sequence is get the amount of that it's going up at the difference of the differences, so the plus 10 here, and simply get that 10 and divide it by 2. Always divide it by 2, always halve it, and that gives us 5. And we can actually fill out the first bit of our answer, because that 5 will be the coefficient of the n squared, so it will be 5n squared. Simple. The next bit is a bit more tricky, because what we've got to now do is remove that 5n squared from our sequence. So I'm just going to do a quick table. You don't need to do a table, but it's sometimes a bit easier. And we're going to have our term number, so term here. So we've got number 1, 2, 3, 4, and then the 5th term. Then we've got our sequence here, which will be our 25, 40, 65, 100, and 145. Now, what we want to do is remove the 5n squared from our sequence. So what we're now going to do is add a 5n squared sequence onto this table. So we do 5 times 1 squared, which would be just 5. And then 5 times 2 squared, which would be 20. 5 times 3 squared, 45. 5 times 4 squared, 80. 5 times 5 squared, 125. And what we're going to do is remove that from our sequence. So we're going to get our sequence and just remove or take away the 5n squared. See what we're left with. So 25 take away 5 is 20. 40 take away 20 is 20. 65 take away 45, 20, 20, 20. So what this is saying, that once we remove the 5n squared, there's still 20 left. And so all we need to do to our sequence is just add that 20 on. So when considering which transformation has happened here, it's tempting to say it's some sort of rotation because it has flipped, but the size has changed, and anytime the size changes, we know we've got an enlargement. So the first thing I'm going to do is write down the fact that it is an enlargement. And anytime the size changes, it has to be an enlargement. And the next thing I'm going to do is realise, well, we've got a point here, which is the right angle, and we've got the same point here. So what I'm going to do is I'm just going to draw a line that connects those points. And this is the method for an enlargement. And we're just going to connect those points up. And we've got the one to the side of it is here, and it actually ends up there. So I'm just going to connect those up as well. And we've got the remaining one as well, so let's connect that one up as well. And what do we notice? Well, we notice that all three of them go through this point here, and that's what we call our centre of enlargement. And well, what happens with the shape? Well, it kind of goes through the centre of enlargement, which is unusual. And as soon as we have it go through the centre of enlargement, we know that the scale factor, so the scale factor, is going to be a negative, so it's going to be minus something. Well, how big was it before and after? So let's just have a look at the squares at the bottom. So there were 2 squares at the bottom on our original, and on the new one there's now 4. So 2 times what is 4? Well, 2 times 2 is 4. So the scale factor is going to be minus 2. And our centre of enlargement, and this is the coordinates of where all the points cross, so that's going to be 0, 2. To find the length of the rectangle, what we're going to do is we're going to get the area and we're going to divide it by the width. Now, the question says that it wants the minimum length, so we want the length to be as small as possible. Obviously, to do that, we want the area to be as small as possible. If the area is smaller, the length will be smaller. But let's have a look at a couple of fractions. So let's have a look at a half and 1 over 100. Which one of those fractions is the smallest? Well, it's 1 over 100, but what do you notice about the denominator? That as the denominator gets bigger, the fraction gets smaller. So to make something smaller, we actually want the denominator to be as big as possible. So we want the width to be as large as possible. So we're going to find the lower bound of the area. And an easy way to find a lower bound is find the accuracy. Well, it says the accuracy is to the nearest 10. And what we're going to do is halve that. So half of 10 is 5. And then we're going to take it away from the area. So it's 98,540, take away 5, which will be 98,535. Now for the width, we're going to do the same thing, half the accuracy, half of 10 is 5, but we're looking for the upper bound, we're looking for the biggest it can be. So we're going to add that on, 1, 2, 3, 5. And when you do that calculation, you get the answer of 79.78542, blah blah, and it says it wants it to 4 decimal places. So we're going to do 79.7854. We're going to start by just drawing the line y equals minus 2. So the line y equals minus 2 will be a horizontal line at minus 2. Will be down here. Next we're going to do the line x equals minus 1, and that will be a vertical line at minus 1. Now here's a bit of a problem. We've got no equal to underneath it, and whenever we don't have an equal to, we do a dash line. So we're going to do a dash line here. Okay, the last graph is a little bit harder. We've got I'm going to do y equals x minus 3. And it's going to be a perfectly diagonal line, but down to minus 3. So it's going to be this line here, about there. But it's going to be dashed because we don't have an equal to. So it's going to be a dashed line like that. So if they have an equal to underneath, then it will be a solid line. If they don't have an equal to underneath, it will be a dashed line. Okay, now we've got to work out where the region is. So we've drawn the lines, and the lines are either dashed or solid, and so they're perfect, but we've got to work out where the region is. So we can see on the first one that y is greater than or equal to minus 2. So it's going to be above this line. Okay. You can see on the next one that x is greater than minus 1, so it's going to be this side. So we've already narrowed it down to somewhere in this region here. And here we're given that y is greater than x minus 3. So what we do here is we pick a point. So I'm going to pick a coordinate, and I'm going to pick 0, 0. 0, 0 is always my go-to one. Write out the equation, and I'm just going to put a box here. So x minus 3, and fill in the coordinates for 0, 0. So 0, blank, 0, minus 3, 0, blank, 0 take away 3 is minus 3. So what is 0 compared to minus 3? Well, 0 is greater than minus 3. And therefore, this coordinate is on the correct side, because if we look, we've got y is greater than x minus 3 is our region that we're looking for. So we're looking for that, that's good. And so our region will be anywhere in this bit here. Anywhere at all. And you're asked normally to mark it with an R. I'm kind of colouring it in just because your R can be anywhere within this region. It can actually be at 0, 0. Anywhere within the yellow region would give you the mark. So we know that the cuboids are similar, so there's going to be scale factors. And we're given the two surface areas, so we're going to first of all start there. And we know that there's going to be a scale factor between them. So what do we times the 9 by to get to the 272.25? So we're going to do 272.25, the big one divided by the small one, to find out what the area scale factor is. And when we do that, we get 30.25. So the area scale factor is 30.25. Now this question is all about volume, but we're going to work a little bit backwards and we'll find out that the area scale factor is the linear scale factor squared. So we're going to work out what the linear scale factor is. So to find the linear scale factor, we're just going to square root the 30.25, the area scale factor. And when we do that, we get the answer of 9. So square root, 5.5 even. Didn't sound right. Okay, so when we square root that, we get 5.5. Now, we know that the volume scale factor is equal to the linear scale factor cubed, because there's 3 dimensions. So we know it's going to equal 5.5 cubed. And so the volume scale factor is going to be 166.375. Okay, so that's the volume scale factor. Now we're given the larger cuboid has a volume of 8984.25, and we're looking for the volume of the smaller one. So with scale factors, to get from the smaller to the bigger, we times it. To go the other way, we just divide. So we're going to divide this by 166.375. And then when we do 8,984.25 divided by the volume scale factor, 166.3275, we get the answer of 54. To start off this question, you need to realise that EGH is a right angle triangle. And if I draw it in on the diagram, and then let's draw it as a two-dimensional right angle triangle, and hopefully we can see how to answer it. So if we put in the values, 4 centimeters there, 5 centimeters there, and we can find length EG by using Pythagoras. So let's try and put in some Pythagoras. So we've got EG squared equals EH squared plus GH squared. And I'm just going to put tram lines down. Okay, so EH is 4, so it'd be 4 squared. And GH is 5, so it'd be 5 squared. And that's going to equal 41. And we're going to square root both sides. So we've got EG equals 6.403 blah blah blah. Okay, so that gives us what EG is. So we know that this is 6.403 blah blah blah. Now we're looking for angle GEC. So we need to draw in another triangle onto our diagram. We'll do this a different colour. So GEC, the triangle would be here. Okay, and so I'm just going to draw that triangle. as a two-dimensional triangle. And again, it's a right-angled triangle. The height is 6. The width, or the base of the triangle, is that 6.403 blah 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 that we've got. And the angle GEC is actually this angle here. So this is angle GEC. Okay. And we can show it like that. Now, to work out what GEC is, it's not going to be Pythagoras anymore, it's going to be trigonometry, because we're looking for an angle. So we know that we first of all label the sides. So we've got the opposite, we've got the adjacent, and we've got the hypotenuse. We're not using the hypotenuse at all, but we are given the opposite and the adjacent. So it is going to be TOA, and those of you should know this off by heart, that the TOA shows us that the opposite will be over the adjacent. So we have tan GEC equals, and that's the angle, equals the opposite over the adjacent. And let's put our tramlines in. Okay, so let's just put in what the opposite is. The opposite is 6, and the adjacent is that 6.403, etc. And I'm keeping it in my calculator so I can make sure that I don't lose any accuracy. You can actually round it to 6.403. Just try and round it to a sensible degree of accuracy, say 3 or 4 decimal places, and that's fine. If you round it to, say, 6, then it's going to have a big influence on the answer. I'm going to inverse tan both sides to get rid of that tan, and so that would just leave angle GEC. I normally just put a little thing there to show it's an angle, and we're going to inverse tan the 6 over 6.403. Now in the calculator, what I'm going to do is type in second function tan to get the inverse tan, and then in the bracket do a fraction button, then 6 over, and then I type in answer because 403 was my last answer. It just keeps the accuracy up. It's absolutely fine. You get full marks if you write inverse tan of 6 over 6.403 and just leave it at that. That's fine. And so angle GEC is 43.138, etc. Now we don't need any more accuracy in that because it says that the answer should be to 2 decimal places. So all we need to do is round that to 2 decimal places, which will be 43.14. It's always important with these questions to realise what the normal graph will look like before we have a look at what the new function will look like. So it's always good to remind yourself what a y equals sine x graph looks like, and it fluctuates between 1 and minus 1, if I write a minus 1, and it goes up first of all at 90, goes back down at 180, down to minus 1 at 270, and then back up at 360. So it's just a simple sketch to help us figure out what's going on with the transformed one. So first thing I notice is there is a negative here, which just means it will be flipped in the x-axis. So this would become like this. And there's also a 2 there, so we're multiplying all the y coordinates by 2. So instead of this going down to minus 1, it will start by going down to minus 2, and it will go up all the way to 2. So we've got a nice idea of how this will look, and so we're going to just start plotting this now, I think. So it will go down at 90, which is, so there, to minus 2, back up to 180 at 0, and then back up to 2 at 270, down to 360, and then it will just go again, 540, up there, and then back down. Not the best graph I've ever drawn, but I think the examiner will understand that I know what the graph will look like, so don't panic about making too many mistakes when you're drawing curves. Just try your best to get it as low as possible, but don't go back and start feathering the lines or anything. So we're finding the area underneath this graph, and that's how we're going to estimate the distance, because the distance is the velocity times the time. And so if we work out the area under the graph, then we've got the distance. But the issue is that we don't understand things like calculus yet, and we've got to use this thing called the trapezium rule. Now for the trapezium rule, what we do is we draw these lines up and we draw little trapeziums, like so, all the way up it, and in regular intervals. So here we can see the interval is every 2 seconds, and we draw these little trapeziums. Now it's often helpful to actually label them, so I'm going to label them A, B, C and D. And the formula for a trapezium, or for the area of a trapezium, is half brackets A plus B close brackets times H. Now A and B are the parallel sides, and H is the perpendicular distance between them. So let's do this for the area of A. So it's going to be half brackets. Now A and B are the parallel sides, so it's going to be this side here and this side here. So that would be 2 plus 1. H is the perpendicular distance between them, so this bit here. So it's on its side, so the height is actually the width, isn't it? So we're going to times that by 2, and that gives us 3. Okay, and you notice here that the half and the times 2 actually cancel each other out, so all we need to do is just add the A and B's together. So to find out what B is, we're just going to add the 1 and the 2, and B will equal 3. To find out what C is, it's 2 plus 5, which is 7, and to find out the area of D, it's going to be 5 plus 10, which is 15. So that's a bit of a quicker way of doing it than having to type it into the calculator each time. Then to find the total area, it's just going to be all of those added together, which will be 28. Now notice, this is useful for some questions, notice that actually there's a bit of a gap here, and I'm just going to shade it in green. It's a bit of a gap between our trapezium and the actual distance under the curve. So here the trapezium is actually adding on a little bit more area than we want it to. And what you'll find is a curve that looks like this, the trapeziums will actually add too much, so the area will be too big, and for curves like that, the trapeziums will actually not give enough area. So sometimes there's questions on whether it's an overestimate or an underestimate, and that's how you can tell. So when we have two equations that are both linear, we obviously do solving through elimination. But here we've got a kind of quadratic-y, kind of circular graph on our second one. So we're not going to be able to use the method of working downwards and eliminating the x or the y's. But here what we can do is we can solve through substitution. This first thing says that instead of y we can write 5x. So what we're going to do is just write out the second equation, but instead of y we're going to write 5x. So we've got x squared plus, and instead of y we're going to write 5x, we're going to put it in brackets because we're going to square it, plus 10x equals 111. So we can actually create a quadratic from this situation. So we're going to just square that. So that's going to be 25x squared plus 10x equals 111. I'm going to just put our solving lines in. It's not much solving to do, because all we need to do is take away 111 from both sides to get it equal to 0, which we need to be able to solve the quadratic. So x squared plus 25x is 26x squared plus the 10x, and we're taking away 111 from both sides, so that will equal 0. So looking at the question, it says 2 decimal places. It's a calculator question. Chances are we're going to be using the quadratic formula. So for the quadratic formula, we need to find out what a, b and c are. A is the coefficient of the x squared, which is 26. B is the coefficient of the x, which is 10. And c is the number on its own, which is minus 111. So we're going to substitute those into the quadratic formula, which is x equals, and then we put our fraction in, and we've got minus b, and I always put them into brackets, plus minus, and you'll see why if you ever have negatives, so you can get in real problems when you have negatives. It doesn't take much longer to put them into brackets. Minus 4 times a, which is 26, times c, which is minus 111. And then all of that over 2 times a, which is 26. So we're going to do this once with a plus there. And so when we have a plus there, we get 1.882, blah, blah, blah. And when we do it with a minus there, we get minus 2.267, blah, blah, blah. But the problem is those are x values. And when we solve, we've got to also find out what the y values are. Well, we actually have a really nice way of finding out the y value, because if you look at this first equation, it says that y equals 5 lots of x. So all we need to do is multiply these x values by 5. So we're going to times that first one by 5, and we get 9.414, blah, 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 times the second solution of x by 5, and we get minus 11.337, blah, blah, blah. And so when we round those to 2 decimal places, which is what the question asks, we can have 1.88 and 9.41, and we have minus 2.27 and minus 11.34. So to find the shaded part of this diagram, we need to first of all work out the volume of the smaller cone, which is at the top. Then work out the volume of the larger cone, which is the whole cone shown, and then take them away from each other. So the radius for the smaller cone is 4, and the height is 5. And the radius for the larger cone is 20, and the height is the 20 plus the 5, so it would be 25. So I'm just going to label them A and B. And so why don't we work out the volume for B first? And the formula for the volume of a cone is 1/3 pi r squared h, with h being the perpendicular height. So it's 1/3 times pi times 20 squared times 25, which is going to be 10,471.975, blah, blah, blah. We're going to work out the volume for A, and this time it will be 1/3 times pi times the radius now is 4, and the height is 5. So that will be 83.775, blah, blah, blah. So to work out the shaded bit, we're just going to do the volume for B, take away the volume for A. So it's going to be 10,471.975, take away 83.775. And all those I'm going to keep in the calculator to keep the accuracy. And that gives us 10,388.199, blah, blah, blah. And to 2 decimal places, it's going to be 10,388.20. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.